Okay, today we're going to talk about the inverse trig functions. Today we're going to talk about their derivatives, and then tomorrow we're going to talk about integrals involving them. First off, you probably remember from last year that none of the 6 basic trig functions have an inverse that is a function, and this is because they're periodic, so they don't pass, the inverse does not pass the vertical line test. So what somebody decided to do was to restrict the range on those inverse trig functions so that they would be functions. So right now what I want you to do on your own is I want you to just go through and name the domain and the range of all 6 of those graphs. And be careful about parentheses and brackets. No, these graphs they've stopped. We've restricted the range so that they are functions, so they do not keep going. We've restricted the range only. Harry, you're being very disruptive.
I'm not trying to.
Well, it doesn't matter whether or not you're trying to, but you are. Yes, hold on just a minute. Yes. All right, the one that I really need you to be able to know is arctan. You need to be able to visualize that graph in your head from here on out. Well, maybe not by tomorrow, but in the next few days, you really need to be able to visualize arctan in your head because it's going to keep coming back. What? Arc is the inverse trig function. Okay, remember that, like, this is y equals arc tan x. That's the same thing as y equals tan inverse of x. It's just 2 different notations. Okay, quick review of Precal. Evaluate the following without a calculator. This involves knowing 2 things. One, you may remember this chart from last year where when we did sine inverse and tan inverse, your answer had to fall between negative pi over 2 and positive pi over 2. And then when we did cosine inverse, it had to fall between 0 and pi. And if you'll look at the graphs right up above on your sheet, then you can see that that's the range of those functions. Also, it's helpful to have your 2 special right triangles. All right, so the way that we work this, the arc sine of 1/2. What angle has a sine of 1/2? 30, which in radians is pi over 6. Okay, good. And if the ratio of sides is positive, then your angle is going to fall in the first quadrant because sine is positive in the first quadrant. Okay, arctan of -1. Kind of ignore the negative at the beginning. What angle has a tangent of +1? 45, or pi over 4. Well, tangent is either in the first quadrant or the fourth quadrant, so since it's the tan inverse of -1, I need a 45-degree angle down there in the fourth quadrant. Negative pi over 4. Now, 7 pi over 4 is coterminal with that. However, if you look at the arctan graph, the graph only falls between negative pi over 4 and positive pi over 4. So you can't use 7 pi over 4. You have to use negative pi over 4. Okay, arcsecant of -2 over root 3. I like to think in terms of sine, cosine, and tangent. So this would be the same thing as the arc cosine of what? Right, negative root 3 over 2. Okay, so what angle has a cosine of positive root 3 over 2? 30. 30. But since cosine is negative, I need to find a 30-degree reference angle in the second quadrant, which would be 5 pi over 6. Very good. All right, and then the arc cosecant of negative root 2 is the same thing as the arc sine of -1 over root 2. So what angle has a sine of -1 over root 2? Pi over 4. But arc sine is either in the first or the fourth quadrant, and since it's a -1 over root 2, I need to use my fourth quadrant angle, which would be negative pi over 4. Good. There's not too much of this evaluating going on, but there's a little bit. So we just need to go over it quickly. Okay, more formulas. Yes, you do have to memorize them. However, the good news is that it looks like there's 6 of them, but there are really only 3. Because what's the relationship between the derivative of arc sine and the derivative of arc cosine? Arc cosine is just negative. Same thing with arc tan and arc cotan. If you know the derivative of arc tan, arc cotan is just the negative of it. Secant and cosecant. So all of your cos, cosine, cosecant, cotangent are negatives. Okay, so you really only have to focus on 3 of them, arc sine, arc tan, and arc secant. And between those 3, the only 2 that come up regularly are arc sine and arc tan. So let's just concentrate on those for now. All right, so basically if you're taking the derivative of the arc sine of u, where u is the argument, it's 1 over the square root of 1 minus whatever u is squared, and then times the derivative of u. Sometimes I think it's helpful to identify what u is and use a u substitution, even though we're taking the derivative. So like on number 2a, what would u be? 2x. All right, so my formula is 1 over the square root of 1 minus u squared. What's the quantity u squared going to be? Either 2x in parentheses squared or 4x squared. I don't care how you write it, but if you write it as 2x, the quantity squared, make sure you've got parentheses around 2x. And then I need to multiply by what? 2. And you're done. Yeah, I mean, if you memorize the formula, it's not hard. All right, arc tan of 3x. What would u be? 3x, yeah. All right, so your arc tan formula is this next one. So what's it going to be? 1 over what? 1 plus 9x squared times what? 3. Okay. Okay, the arc sine of root x. Try that one on your own. Everybody okay? No, you don't need to simplify. If you really, probably if I were working this problem, I would write it as x to the negative 1/2 over 2 square root of 1 minus x. And that's the same thing, but really, I'm okay with just that first step. Okay. Okay, D. Arc secant's the one I struggle with because I have trouble. I have the other two memorized, but I have trouble memorizing the arc secant. All right, what would U be? E to the 2x. And sometimes it's helpful to go ahead and say what du would be. Du would be 2e to the 2x. Good. Okay, so your arc secant formula is u prime on top, so 2e to the 2x divided by the absolute value of u. Do I need absolute values around e to the 2x? No, because e to the 2x is always positive, and then times the square root of u squared minus 1. What do you get when you square e to the 2x? E to the 4x.